Welcome to OARC 32 and to San Francisco. For those of you who are here for the first time, I'm Keith Mitchell. I'm president of DNS-OARC. I'm just going to run you through a few administrative things, and then I'll hand you over to Paul Ebersman, who's on the board. Okay, so you've probably figured this already, but the Wi-Fi connectivity here, we're using the Nanogs network. So the SSID is Nanog, password, and user ID, Nanog, all lowercase. For the breaks, you'll see that the coffee is outside with registration. For lunch, we're going upstairs into the hotel foyer. I'd strongly recommend you use the stairs at the back of the hotel to do that, and don't get sucked into the horrible mess of escalators and lifts and doors that don't work at the front of the hotel. The toilets are just outside. Dietary restrictions during lunch or any of the breaks. If you have any concerns, then please speak to the hotel catering staff or to Dinesh, who will be able to advise anything that meets your constraints. In the event of an emergency, there will be an alarm. I think we're supposed to wait for 30 seconds to see whether that goes on or off or not, and then if there's a requirement to evacuate the building, e.g. for a fire, then there will be an announcement to evacuate the building and basically go out the doors and out the entrance to the back of the hotel. In the event of an earthquake, you do not evacuate the building, you basically stay where you are and hide under the tables and all the usual earthquake things. We've been warned by the hotel, please be careful about the physical security of your laptops and other items. We are in a tourist trap area. There are professional thieves around. We're going to lock the room at lunchtime, but please just be careful with your stuff. Matt Poundsit has become a RIPE Atlas ambassador, so if you're interested in acquiring a RIPE Atlas Pro for use in North America, then talk to Matt during one of the breaks. Also, we're not doing a PGP signing this time. We're going to do that once a year. So with 3 workshops a year, this is not one of the workshops that we do that for. We have a lightning talk slot at the end of the day. I think we've had 4 or 5 submissions for that already, so there's maybe space for 1 or 2 more. If you want to submit a lightning talk, please do so ASAP and no later than the lunch break, so that the program committee can select the lightning talks during the lunch break. We have a social event this evening. After 3 boat trips in a row, we are firmly on dry land this time. It's the Patriot House pub, which is at the Embarcadero Center, which is this twisty maze of ups and downs, but we'll give you directions. You need to register for that. It's also possible to register if you want to bring a +1 who's not around for today's workshop around. That's at 6:30. Make sure that you have a ticket for that and your name badge. We're experimenting with the format a little bit this time. Usually we have a 2-day workshop. What we're doing is we're having a 1-day workshop today. And then tomorrow we have a couple of additional events. We're doing our first OARC member roundtable. So that is for OARC members only and those who explicitly invited or registered for that. There's still a bit of space for that. If you're an OARC member, you want to come along, please register for that, and we'll see you tomorrow afternoon. And the idea is that instead of everybody sitting facing the front and receiving information, it will be a more interactive discussion. And again, that's a little bit of an experiment. If you're a member, if you have particular topics you want to talk about, let us know. The other thing is that we're helping out the Encrypted DNSSEC Deployment Initiative tomorrow morning. And they are having their meeting, which is a separate meeting between 9 and 12:30. If you're interested, there's Glenn and various of the Comcast and other participating organizations behind that around. There's a separate registration for that. And for everybody, if you're coming back to the events tomorrow, please hang on to your badge. You will need that for either the morning or afternoon sessions. We're webcasting on the OARC YouTube channel, so please try not to emit any spurious beeping noises or EM radiation. We have a single microphone at the front here, so if you have questions to ask, please make sure that you line up at the microphone and identify yourself and your affiliation for the benefit of the people on the webcast. Remote participation, there's a Jabber room. That is open to anyone with a Jabber account somewhere. If you're a member, you should have a Jabber account. If you're not a member, you'll need a third-party Jabber account for that. And then we're on the various social media platforms at #OARC32. I think we've got all our slides, so thank you, speakers. But if you've got any updates or special requirements, please let me or Shumon or anyone at the front table here know. We're running one-day workshop today, so the timekeeping is a little bit tighter. But as a speaker, you will get the countdown from the timekeeper at the front, and be aware that that's a countdown to the end of your talk. There is still time after the end of that countdown for questions and answers. And you know, the other thing I'll say is that all of the speakers who come to our workshop do so on their own time and expense, and we wouldn't have it without them, so we very much appreciate the speakers. Finally, we have a conduct policy. You all checked a box to say that you adhered to that. It applies to all OARC activities online and in person. Please, everybody, respect that, respect your fellow attendees. If you feel uncomfortable that somebody is not complying with the conduct policy, please let anybody who has got a crew badge know. You'll be able to identify staff, board, PC, and our crew of volunteers. There are various colored dots on their badges. And also, we have a bunch of first-timers here, so if all the old farts and usual suspects could make that extra effort to make the first-timers welcome, then welcome to our first-timers. Okay, that's the boring stuff. I will hand you over briefly to Paul Ebersman, who's our newest board member. Paul has come back onto the board after a short break, and Paul has a couple of remarks before we get underway.
Thank you very much, and good to see everybody here. Thank you for coming. We are excited about the program. PC, as usual, did a lovely job with that. We're going to be doing, as Keith said, the member roundtable tomorrow, and this is really a chance. We've had a number of issues, concerns, priorities, and we're looking to get your feedback on what direction you want to see DNS-OARC take, both with the meetings and with our funding and our data stores. I'd like to also thank our continuing patron VeriSign and our event sponsor Comcast. And beyond that, enjoy. And yeah, hit us up if you have any questions or concerns.
Thank you, Paul. Okay. We try and keep the non-operational content to a minimum at these workshops, but I think you know, we also try and make sure that we inform you all about what's going on at OARC. We always have some new members and two who workshop for the first time and some non-members. So before we continue with the content, I just want to run you through a few things which will probably be very familiar to the members, but I just wanted to share with the rest of you. Why is OARC here? We're basically here to make the DNS work better. And one of the interesting things about the DNS is that it's kind of like the intermediation layer, the glue that a lot of other internet things hang together. It's an interesting intersection between research and operations, between data gathering and insight, between abuse and abuse prevention and mitigation and detection. So OARC's been around for about 15 years now, and we're here to help researchers. One of the things that researchers want is live operational data. So we're here to provide a channel between the operators and the researchers. There's a whole bunch of tools which kind of fit in the, they're not implementing the DNS, but rather they are there to measure and instrument and test and stress and other things. And we have developed over the years a set of open source tools for that. We have also become the home of a whole bunch of orphan open source tools which were useful but in need of love. So we have quite a large catalog of open source tools now. It's also about relationship building. bringing all the people together who work on this stuff, and being responsible about how we share the information, whether that's data that's gathered directly off of the DNS infrastructure itself, or whether it's also about the knowledge and know-how and intelligence that you may all share on particular things that are happening. And the workshops are a very key part of that, but it's not just about the workshops, it's also about wider outreach. We have a community of around 100 members. That's reasonably constant, but I'm pleased that we're able to welcome some new members recently, and also some members who are supporting it at a very high level, so that's great. But sometimes it's a little bit difficult to explain in layman's terms, explaining to your mom what is it that OARC does. Are we a library? Well, we're kind of like a library because we've got a big data collection. Or are we more like a learned society because we're talking and sharing and debating? It's certainly the place where the DNS experts work together. And if you're not quite sure what it is, my recommendation is get more involved. The more involved you are, the more obvious it will be as to what it is that we do and what the benefits are. We have a bunch of technical resources, 250 terabyte plus data set. Most of our infrastructure is down the road in Fremont here. That includes analysis and storage servers, but we have a program for upgrading them at the moment. I mentioned our open source software. You can find all of that mostly on GitHub with some documentation on our website. There's a bunch of test services that we do, and we also have some secondary sites to diversify our infrastructure. Participation for members is a bunch of various levels. We recently, for the first time in 5 years, slightly increased our fees to take into account inflation. So if you remember, please make sure when you're doing your budget and or purchase orders for this year that they are at the correct new amount. We don't just have pay-as-you-go, though. We also have a couple of categories where smaller organizations can participate either in kind or a significantly reduced membership level. I'm not going to go on about the governance stuff, but just to say that we are, I believe, industry best practice in terms of non-profit membership organization. We're financially stable and self-supporting. More money would be great, but we have for many years been sustainable. We have a stable self-governing structure. The board is elected. All of the staff that you see here are contractors of varying degrees of full-time through part-time. But we have a whole bunch of volunteers, the program committee, and a bunch of other people who help out with various things. Board had a couple of changes back at the AGM in October. As I say, Paul Ebersman, who used to be a director, is back on the board again. And we're also welcoming Ben Wolverander from Elnut Labs, who's now a board member as well. All the staff are here, so we come from a range of locations, but it's always great to bring the team together in one place. Program committee, again, this is pretty much the same as last year, although, again, I'm glad to welcome Ulrich Wisser to the program committee. And also, I thank you to Robert Edmonds, who's served his term limit on the program committee and is departing after this workshop. Workshops, we did 2 of these a year. We're experimenting this year with 2.5 workshops, so this is the one-day one. We try and co-locate them with Right Nanog and ICANN meetings, although that makes the cost of running the workshop more expensive because you get to be in fancy hotels with nice food like this. In general, the feedback we get from the attendees is the travel time that saves them is worthwhile. But the workshops don't just happen by magic, and it's great if we can get sponsors and patrons to support them. In particular, we're grateful to VeriSign for being our workshop sponsor for this year, our workshop patron for this year, and for Comcast for being the specific sponsor of this workshop. So, in summary, it's about knowledge sharing, it's open source software, various online platforms and services to provide testing and support of the community, the data set collection and sharing, and allowing operators and researchers. You can think of our workshops is a global DNS NOG, but as an organization, we're a bit more than that as well. Next workshops, these are both 2-day workshops. We don't usually, one of the reasons that we spread the workshops co-location around different events is to spread across the global coverage. Unfortunately, because we're moving from 2 to 3, we've had to shuffle the routine a bit. So this is the second of 2 consecutive US meetings, and then later on in the year we have 2 European meetings. But next year in 2021, we'll shuffle that up a bit more. But in May, we'll be co-locating with the ICANN IDS and ROW and GDD events, and that will be in Paris, France. And then in September, we still need to confirm the venue, but the intention is that we'll be immediately before the RIGHT meeting in Milan, Italy. Again, a reminder about the conduct policy. And if you're not a member, here's a bunch of reasons why you should consider being a member. And I hope by the end of today, you'll consider doing that. Please come talk to me or any of the team if you'd like to sign your organization up or at least find out more about that. And the testimonial comes from some of our members who have said some very nice things about us. So, okay, we're not going to do questions right now. Okay, that's me done with my bit. Now you get the interesting stuff, and I'll hand you over to Ralph Dolmans as this morning's session chair for the first of our presentations.
Right, good morning. Thank you, Keith. I'm Ralph Dolmans, member of the OARC PC. In this session, we will have 3 nice talks, with the first one being from Brian Somers. Brian works for Cisco on OpenDNS, and he will talk about their experiences in implementing DNSSEC validation in OpenDNS.
Morning. So I'm Brian Somers. I've worked for OpenDNS and now Cisco for 9 years now, I guess, which is a very long time. And we recently decided it's time to do DNSSEC. We actually decided this 2 years ago, and we're now at the stage where we can actually present what happened. So our journey to DNSSEC involved 3 to 4 developers at any given time for the past 2 years. We found it very difficult to parallelize tasks, so really we only had 2 things going on at any given time, and there was pretty much 2 developers working on each. We should have done some more pairing than we did. We didn't. It's sometimes hard to justify the time. But we did try to kind of keep everybody involved in what we were doing. We had various technology briefs explaining exactly how we were tackling certain problem areas. We used agile development, so we had planning meetings at the start of the week and stand-ups each day. I think most of the industry does that these days. And we encouraged everybody to review everything all the time. Everybody should be aware of what's going back into the code base and why it's going in there. And we're all DevOps. We all manage the DNS infrastructure at Cisco as well as develop the code. But we have a few kind of better DevOps than us that we got involved as well to do some analysis of performance problems and that sort of thing. So we really looked at DNSSEC and we split it into 3 parts. They're fairly obvious parts, although the third is maybe a little bit less obvious. The first step was to send the do bits upstream, just send the do bit and see what happens. The next part was to actually take the results and put them somewhere, so we started storing them in the cache. And of course, then once they're stored in the cache, to do the validation. And the third part, so bearing in mind that we just did the validation, we didn't change what we were responding with, so we'd still give you exactly the same answer as the client that we always did. And then the third part was to stage the enforcement of DNSSEC. So once we knew what the answer was and whether it was valid or not and what all of the security records were, we then allow individual customers or individual IP addresses to actually support that. So really we've been deploying this stuff for the last 2 years and it's been a secret, nobody's known about it. There was a little bit of a kind of hiccup in the whole process though, which was fragmentation. OpenDNS turned off fragmentation a very long time ago. Fragmentation is evil. Ask Dan Kaminsky about why. There are a ton of different exploits that you can do against fragmentation, specifically just forging the second fragment, dropping it into the IP stack of the resolver, and then soliciting some sort of request upstream. So we looked at this and thought, okay, well, DNSSEC needs big responses, so we're going to have to support fragmentation. What are we going to do about that? And my analysis of it, which wasn't a great analysis, was that IPv4 is the problem. Fragment reassembly in IPv4 is all based on a 16-bit number. It's easy to guess what that 16-bit number is, or it's fairly easy. IPv6 is better, right? I mean, it's got a 32-bit number, and it uses PMTU for to figure out what the fragment size is. So that's got to be good. So we came up with a mechanism that basically said we'll turn on big packets, we'll accept fragments, and then we'll treat stuff that comes in second and subsequent fragments as suspect. And if we actually need it, then we'll query it again over a better protocol. That was the plan anyway. So looking at our kind of our path for the last 2 years, above the line here we have what happened on the development side, and below the line what happened on the deployment side. So really we kind of did what you'd expect. We started developing the fragmentation and the do-bit side at the same time in April 2018. We pretty much got that do-bit stuff done by September. We got the fragmentation stuff done by November. It was all a lot slower than we thought it would be. There's a lot of RFCs involved. I'll kind of point them out later. And really it wasn't until April 2019 before we actually started the validation framework. The validation framework was a bit of a pain in the ass. Figuring out the chain of trust was harder than expected. And we only actually got into a position where we could actually implement the validation for RSA signatures in July, and then finally the elliptic curve and the DSA stuff in November. We started deploying fairly close to the start of development, so the idea is to deploy as you go along. As I said, like, the responses were still all the same, so there was no visible changes as far as the customer was concerned. Maybe they'd experience a little bit of a latency. We put the do-bit stuff in our live feed implementation. So our live feed implementation is kind of a T of production traffic with responses firewalled that we use to statistically see how we're doing. And we enabled fragments in February 2019. We went along, started attempting fragmentation because, of course, our validation, we'd done all of the validation work by July 2019, so we started deploying that. I say attempt validation because actually that wasn't too easy. We attempted it, and then we had to disable it again, and then we had to do some fixes, and then we attempted it again, and then we had to disable it again, and that went on over and over again until we finally discovered wildcard negative trust anchors, and then we were able to actually disable it for certain hierarchies that were troublesome. And that kind of freed us up around October, November time to being able to leave it turned on fully. So that was turning it on upstream. Again, we weren't responding with anything interesting to customers until January, and we kind of hit our initial kind of customer deployment, if you like. And GA is soon. GA is kind of planned for this month or next month, but we'll see how that actually pans out. So developing in parallel was kind of standard stuff. I'll kind of whiz through this chart. Allowing fragments, I already mentioned the idea was to get the firewall to mark where the second and subsequent fragments started, and then to get the resolver to distrust them. And if it needed any of those RR sets that it distrusted, then it would requery them upstream over IPv6 or TCP. And then on the do-bit side, there was a little bit of work to do. We had to start understanding these RR sets that we were getting back. So we had to understand RR SIGs and DSs and DNS keys and things like that. We had configuration that allowed us to turn on and off the do-bit upstream. Unfortunately, it's kind of useless to turn on the do-bit on a running resolver because, well, you've got all this stuff in the cache that has no signatures, and you're missing security records, and it's very difficult to recover from that. We cache the RR SIGs with the records, so if a record doesn't have an RR SIG, then it doesn't have an RR SIG. There's no kind of recovering from that. It's just a failure. We had to work on storing security RRs, so RR SIGs get stored with the records. We took the approach that things like NSECs and SOAs are not stored with negative cache entries. They're stored as separate entries in the cache, and then they're referenced from the negative cache entries. That actually makes things very difficult, which I'll kind of talk a little bit more about further down the road. And then, of course, for internal testing, we had to implement a way for us to be able to query the resolver and actually see what it was storing in the cache, et cetera. So we had to implement the do bit as for clients, but only certain clients. Did I go too far? Yeah, so allowing fragments. So that was just a huge debacle. It was a huge mistake in the end, I hate to say. So it took us absolutely ages to implement it. We kind of got most of the kind of caching of these secure or the suspect markings done in a few months, but it took quite a few more months before we actually did anything about it in terms of requerying upstream. So we got all of that working and up and running, and then we have an internal group called ASIG, who are a security pen testing sort of code review team. So we gave it to them to have a look and see if there were any security vulnerabilities that they could see. There was good news and bad news. The good news was there was no security vulnerabilities in the resolver, but the bad news was it was a bad idea. So we worked with ASIG on that bad idea, and the bad idea was eventually presented at DEF CON in August last year. And it talked about a way of exploiting bugs in Linux that implements IPv6 fragmentation in the same way as IPv4 fragmentation, that allows you to do a single packet attack on a recursive resolver and poison the cache. So anyway, we did some quick measurements because we'd already deployed fragmentation to production, and we noticed that, well, there was really about a tiny percentage of additional traffic going upstream with large packets that we cared about. So we turned off fragmentation again. And the do-bit deployment was much more straightforward, although there were a few surprises. One of the big surprises, which everybody here will laugh about, was the EDNS flag day stuff, where we send EDNS, there's no response, and then we send a query without EDNS, and we get a response, and we say, well, they don't support EDNS, and we turn it off. Well, that's a really bad idea, because if you've got a DNSSEC supporting name server that supports DNS or DNSSEC, and therefore has to have EDNS, and you turn EDNS off, well, guess what happens? So that was kind of a little surprising for us, but it was kind of funny because we'd already implemented the change, but we were having discussions with management about whether or not we could deploy it. So statistically, and I guess it's worth mentioning that these statistics are based in Palo Alto. They're not global, so they probably don't apply to places like China and Hong Kong, that sort of thing. So statistically, the number of authoritative requests we send upstream hardly changed at all. There's a few more TCP queries as a result of DNSSEC. As it turns out, elliptic curve signatures are way smaller than all of the RSA stuff that we originally started with. So actually, a lot of the response packets aren't as big as we first thought they'd likely be. So really, we're talking about TCP increases by about 5 times. But because TCP is like point nothing of our UDP traffic, it doesn't really matter. It doesn't affect us. We can hardly see it. It's difficult to actually identify in graphs. The most interesting kind of blow that we took was the cache size. So the cache size in our implementation it's just a big circular buffer. So the cache size stays the same, but we chew through it 5 times as fast with DNSSEC enabled. And that's because of all the RR SIGs and DNS keys and DS records that we have to store. Network traffic, I was a little bit surprised about this. The same amount of upstream traffic goes out. As you can imagine, we're asking the same questions. There's a do bit set, and that's it. The increase in the response number of bytes was only 10% more. So I found that a little bit surprising, because most of what we query are address records, and signatures are bigger than 4 bytes. So how can that be? But, well, graphs don't lie, right? One of our kind of complications was referencing support records. As I said, we store NSECs, NSEC3s, SOA records in the cache as distinct records. The logic being that if you kind of query one of these directly, you should actually see what you got back with a negative response. And the RFCs kind of talk about, well, caching them all as one big blob as a negative response. But, well, then you get weirdness where you query one thing and then you query another thing and you get two different NSECs with the same name, and that's kind of weird. So anyway, we chose to kind of reference NSEC records and SOA records. That got us into trouble. Lots of name servers, especially Cloudflare name servers, probably other people in the industry, sign records on the fly. Signing records on the fly means that you get the same record back with different signatures, so you've got to be very careful about how you deal with them. And of course, lots of implementations give you back different SOA records, so you've got different SOA living on each of your name servers. That's very disturbing because, well, what do you do with SOAs when you're doing validation? Like all of a sudden you've got something that's cached as validated, a negative response that's cached as validated, and the SOA changes and that's no longer validated. So you have to kind of notice that and go off and validate it. So there's a lot of mucking about there. Implementing validation was the final piece, so how hard can that be? This is going to be really easy. We have all of the records in the cache. So all we have to do is hash the RR set, verify the signature, and send a serve file if we don't like it. That's going to be really easy, right? So we're almost done. Well, of course, there was a whole ton of surprises there. NSECs were really hard. So just looking at the first three RFCs, 40, 33, 4, and 5, NSECs were described, and when I initially implemented the validation chain of trust stuff, I did NSECs, but completely wrongly. Like my kind of proof expectations were all over the place. Discovering that trust chain was really, really difficult as well. We implemented it so that we cache stuff as not known, and then later when we actually need to give it to a client, we'll go and validate it. So we'll do just-in-time validation. That's kind of tricky because you then need to kind of figure out where you got the record and where its signer is and where the signer is, etc. And that was just very difficult. It turns out that if you query a lot of non-DNSSEC implementations and ask them for security records, well, they just do all sorts of bizarre things, like from giving you form error when you try to query a DS or a DNS key, to not responding, to returning security records, like here, have a security record, here's a DS record signed by itself, that sort of thing, which is a great way of kind of getting stuck trying to figure out what the validation chain is, because you get yourself in an endless loop. And sometimes you can't avoid accidentally asking one of these non-DNSSEC aware resolvers, especially when you get delegations to self. So you've even got situations out there where you'll delegate to a DNSSEC aware name server, and that has a subdomain delegated to itself, and the subdomain is not signed. So like dealing with that sort of thing and kind of magically knowing that there's a delegation stuck between you and it, and that those records that you've got without RR SIGs are actually unsigned because there's a delegation in between that you didn't know about is hard. When we implemented NSEC 3, actually that shone a whole load of light on how NSEC should be implemented. NSEC is actually exactly the same as NSEC 3, except you don't have closest and closers, they're all implied. So NSEC 3 was kind of hard with RFC 5155, but there was another 7,000 and something RFC that actually said, this is how you should really tackle NSEC 3, which made it so much clearer. It was a fantastic RFC. And of course, SSL, we had to suddenly start using SSL in the resolver, and well, SSL is hard. Everything you do in SSL produces memory leaks, and you've got to be very careful tracking that sort of stuff. So why did it take us so long? Well, we had a ton of other work to do that wasn't really kind of part of the original plan, but kind of fell out of the work. Reorganizing the cache layer. So the previous implementation used to just have blobs of stuff in the cache, and the rest of the code just understood what the stuff was. So we had to kind of structure all of that and make the objects that are in the cache kind of recognized objects, because we work with those objects all the way through discovering an answer and then validating that answer and then updating the cache with the validation bits and dealing with interacting with other threads, because our implementation is multi-threaded. So there's lots of things contending to do the same stuff in the resolver at a given time. The canonicalization of records was something that we ended up tripping over. That was kind of trickier than we thought, because canonicalization of names is quite clear, but canonicalization of the RR sets that are originally defined in 1034 are actually quite tricky, because the names in those RR sets aren't ordered based on the canonicalization that names are ordered in. They're ordered as binary memcoms. CNAME chains were hard because, of course, CNAME chains not only have to have their own signatures hanging off of them, so they need to be implemented as part of these same sort of cache entries. But CNAME chains can also have NSECs hanging off of them if they're wildcard CNAME expansions. So there's all sorts of kind of really, like, that's just really complicated issues that came up while we were doing that. And of course, uncompressed size explosions. So there are all sorts of bizarre implementation of name servers out there that do things like, you look up a PTR record and, well, the answer is, 64K of compressed PTRs. And, well, try uncompressing them and so that you can validate them, and you get yourself into real trouble. So our implementation does some special things with the CD bit when the client gives us the CD bit, which is check disabled, versus when it doesn't. The idea, our intent here is, and we have this implemented for our RRSIGs, but not NSECs. The intent is that when you query normally and you turn on the do bit, you get all of the security records, but you don't get the invalid ones unless you turn on the CD bit, and then you get the whole lot, and you get the record whether it's validated or not. We've done that for RRSIGs, so sometimes you'll see more if you do plus CD. Sometimes you won't see a bunch of the RRSIGs normally. That's not true with NSECs. You just get to see all the NSECs, and you just have to trust that we validated it correctly. There are a lot of bad non-DNSSEC players out there, as I already said. Don't ask them the wrong question. They'll do something bizarre like formair or whatever, and formair turns off eDNS. Like, I was supposed to do something else with formair. There are lots of bad DNSSEC players out there as well. Like, query www.mil, for example. Like, really, the whole mil is just a complete train wreck. It's terrible. Inadder.arpa seems to be great at the top level, but they delegate to all sorts of yobs in the industry that don't know how to sign stuff. Delegations to self are a bitch, as I already mentioned. Like, discovering those interim zone cuts is actually fairly straightforward when DNSSEC is involved, because you can always go to the RRSIGs, and the RRSIGs have signers, and you can climb up the chain that way. But when there's something that's not signed, discovering those zone cuts is a bitch sometimes. And there's even cases where people have waded right into DNSSEC and misimplemented. So there are people that are producing RRSIGs with compressed signers, for example, and, well, really? And, well, apparently we have to support that now because Google do. So what worked or didn't work? Well, DNSViz and the VeriSign site were absolutely amazing. Like, they were hugely good tools, and I'd recommend everybody to follow those links and see what they are. Validation failure logs, so it's really important to kind of record why you think something is failing, because otherwise it's just a big black box at the end of the day. And we've got lots of diagnostics that we can turn on and off in the resolver. We also have a facility called X-Ray, where if you query one of our resolvers from a trusted place and you put .xray.opendns.com at the end of the query, you get a whole ton of glue records that are text records that tell us how we came to that answer. So we've got all sorts of facilities where you can kind of turn on X-ray diagnostics, and then you can force revalidation, and you can see all of the validation results for your given query. Diagnostics are huge. It's very important. Validation locks turned out to be a good idea. So internally in the resolver, two things won't validate the same thing at the same time. They lock against each other, and if somebody fails the lock, they go off and find something else to do and come back to that later. It turns out that around 5 to 10% of our validations actually hit a lock and go off and do something else, which is more than I would have thought. So it looks like that code was a good idea. Enforcement flags were really our kind of coup de grace in terms of deploying this stuff. So being able to actually continuously deploy all the way through our project and having the customers be oblivious to it was brilliant. And DNS crypt, which I'm sure everybody knows is one of the things that we suggest our clients use, fits in perfectly with DNSSEC. DNS crypt secures between the client and the recursive resolver so that they can actually trust the AD bit. So it's a perfect match for DNSSEC at the resolver. We did also discover a huge bug in our resolver where for years and years and years we've been serving glue to clients. So you're not supposed to do that. There was an RFC a very long time ago that assigns trust levels to different sections of different answers based on whether the AA bit is set as well. We've been happily serving glue records for various different reasons. What didn't work? Fragmentation. Well, we wasted a year of our time on fragmentation. First NSEC implementation was terrible. Chain of trust was really difficult. And writing the validation framework was appalling. That was mostly my fault. It was a matter of one person going dark and blocking everybody else for a while. RFCs, the only thing I'd highlight about this is if you're looking into DNSSEC RFCs, don't look at anything less than 4033. Ignore DLV, it's not a thing anymore, it doesn't matter. And one of the things we haven't implemented yet, but we intend to, is all of the signaling stuff so that name servers can figure out what we actually support and don't support. So I guess two final notes. Negative trust anchors are a thing that you'll need if you implement DNSSEC, being able to kind of mark somebody as being a kind of solid no data record is important. So here we've got a DNS key that's no data. We trust everything in our configuration, so that's just an automatic trust. Because it's got no RRSIG, it's an automatic trust, not signed, forget it. And you can, this is visible from the outside world. This isn't in our negative trust anchors, although I'll say that .mil is at the moment. So you can see it via dig and plus CD. And the other big thing that Cisco had a problem with was redirections. We always thought, well, you can't implement DNSSEC because it'll break all of our redirections. We redirect when you go to a bad site and we send you to a website that says we protected you from the bad guy, you're welcome. Well, actually it turns out that we didn't have to do anything with that. We just return records without signatures and kind of say, yeah, sure, it wasn't authenticated. Here's your answer, what are you gonna do? Like, what's the worst they can do? They can, throw it on the ground and not follow it? Well, that's job done as well. So actually redirections work just the same as they ever have. And the code is live. I've put the IP addresses of our non-policy resolvers here. So even if you come from an organization that has some sort of contract with us and has some sort of policy, you can always query these name servers and they'll give you no policy. And they run with DNSSEC, so you can send the do bit, you can send the CD bit, and you can get the responses. And hopefully we're pretty close. There's a few bugs that are still in there that we know about, and there's probably a few that we don't know about. So questions?
Hi, this is Unre at IC. Thank you for the great talk. I share the pain. I just have one small note. The paper about the fragmentation was done by Haya Schulman and Amir Herzberg from the Bar Ilah University. By the time they introduced Kaminsky, had nothing to do with that. That's just clarification.
Yeah, I think so in terms of papers and fragmentation, there's been a lot of talk about this over the years. So yeah, I think it's something that our industry should discuss, maybe having a flag day over, but I'm sure there's lots of differing opinions.
Ralfi Bakamai, thanks a lot for doing this great talk. One thing that wasn't clear to me, so the validation, do you do that when you go in the cache or when you go out from the cache to the client?
So for validation, where we do validation, so we go and we harvest the answer. and once we have an answer, we then validate it. So our validation process is then to climb up the chain of trust until we have a already validated bit stored in the cache, and then we'll validate back down from there. So the normal case is we'll look in the cache and we'll find that the validation bit is already set, so we already know the answer to the validation.
Okay, thanks.
Robert Edmonds, Fastly. So one of the advantages of implementing DNSSEC validation in 2019 versus, say, 2007 or so is that you have the advantage of all the subsequent RFCs, right? I was kind of intrigued by your description of the implementing INSEC 3 in light of, or INSEC in light of INSEC 3. Did you read some RFCs and then start implementing code, or did you read all the way to the end before you started writing code?
Yeah, so the question was in terms of our kind of confusion with some of the RFCs, did we read all of the RFCs first? Yeah, kind of. I've got to be honest here, that a lot of the reading of the RFCs was a cursory read initially and then kind of getting into doing the work. So certainly when I implemented NSEC, I was less concerned about NSEC 3 because that was something that we'd do as a kind of next step. And I assumed that NSEC 3 was more complicated. So my initial NSEC implementation was, and again, this is also because I misunderstood how wildcards work, because I had never implemented a name server, just a resolver, and resolvers don't care about wildcards up until now. So I was doing things like expecting proof of all of the wildcards at every level down to what you were looking up. So yeah, I mean, I guess the short answer is when you implement these things, what you should do is read all of the RFCs first. And what you actually do is you have a look at all of the RFCs and try to discover whether or not there's anything you care about in them. And then you go back to actually looking at the detail. So yeah, kind of guilty as charged.
Tom from Cloudflare. I have two questions. Did you, or are you measuring the CPU penalty for doing all of this extra work in your resolver? And the second point is on the online signing. Did you look at other resolver implementations? Because I would be curious to know how they behave with online signers.
Yeah, so there were two questions with regards to CPU utilization. Do we know how much more we used? I did look at CPU graphs. I couldn't see any difference. But really what I was comparing was the same kind of location resolver set now and 2 years ago, and looking at the graphs proportionally. And there was nothing. So there was all sorts of optimizations done during the project that might have actually taken some of that back, and there were also hardware updates. So I don't really have any statistics on really how much CPU usage has changed. And I'm trying to think what the other question was. Sorry.
Was the online signing implementations in the resolvers?
Sorry, on?
So you mentioned that in looking at the RFCs, it recommends that you would respond with the same RR set from the cache. And if you online sign, then you get different ones. Do you know what other resolvers do in that situation?
Yeah, so I haven't looked at any of the other implementations. I've just measured behaviors. So one of my favorite kind of behavior testing is Google, of course, and Cloudflare and 9999 are kind of other big tests, and of course DNSViz and VeriSign. So yeah, I haven't wandered into other people's code base to see how they do things because I didn't want to be polluted with how you do things and how I think we should do things, but I don't know if that's a good or a bad thing.
Hi, Tail. A quick question, though. I didn't really understand the different RR SIGs for the same RR set. I understand that online signing was involved, but didn't quite understand how they would have come up with something different other than perhaps validity period. So the two-part question is, A, what's different, and B, okay, it's different, how did that affect your implementation?
So the question is for clarification around why you'd have different RR SIGs for the same RR set. For example, Cloudflare, when you get a negative response from Cloudflare, you look up nonexistent.cloudflare.com, and you'll get back a whole bunch of NSECs and signatures. If you ask nameserver A, you'll get one set of signatures. If you ask nameserver B, you'll get another set of signatures. So if you look up two non-existent records, you can get the same NSECs that you're trying to stuff in the cache with different signatures. So in our implementation, the complication there is that we have to know that actually we're storing this, or we got this NSEC, whether or not it's the same as the other NSEC, because if it's a different NSEC, then we have to churn the negative cache entry for the original. So yeah, just unraveling all of that was the tricky bit.
John Reed, Akamai, what's your policy around negative trust anchors? Do you add them ad hoc as they're found? Do you ever decide not to add one, even if it's broken?
We're still pretty new at actually having this open to the general public, but at the moment, trust anchors can, so the question was, what's our policy around inserting trust anchors? So at the moment, trust anchors can only be done by our team who run the resolvers. Support aren't allowed to create trust anchors without asking us via a ticket. We don't really know what this looks like. I don't want to allow people to enter trust anchors because it's just exposing the people that think they're protected to the big bad internet again. .mil is kind of a bit of a problem because I don't really know who to talk to in the US government to actually solve this problem, but train wreck. And I did try to talk to inadder.arpa, but I didn't get any responses. So generally our strategy is we'll have a meeting with a product manager and a bunch of engineers and make decisions on the fly and then decide to put those trust anchors in, but we try to avoid it.
Thanks.
Paul Lubbers from Newstar. Yeah, there is a draft with some recommendations for when to put in negative trust anchors and what kind of procedures you might have for doing it or not. Also, from past lives at Comcast.mil was horribly problematic. Our bypass was we usually emailed Scott Rose, who had access to the .mil, who could get us contacts, sadly enough.
Okay. Okay, thank you.
Thank you, Brian. Up next is Ed Lewis from ICANN, and Ed will talk about his observations in different ways that name servers will respond to queries with the any qtype.
All right, thanks. This talk is a pre-cycled talk. I gave this talk last week in another venue, and it's not like I'm recycling for OARC. I designed it for here, but I gave it a week ago. So I have some notes from last time, from comments that I got to this talk. So you were supposed to hear this first, but it's been elsewhere. So this talk, it comes out of my using the any query in some work I do. And I began to notice that a couple of places I asked, they wouldn't answer me straight up with the any query response that I had normally been getting for many years. And so this talk is looking at what I do get back, and to give you a reference where this is coming from, there's an RFC. It's the observation, or it's the providing minimal sized responses to DNS queries that have qtype equal any, otherwise known as RFC 8482. Now, this is my original agenda here. I'm going to probably go a little bit quicker to catch up some time here. How many people here are completely unaware of what qtype any is? Very funny. Without shaming yourself, with the first person. Okay, so I'm going to go a little lighter on that. This is not necessarily for the DNS-OARC. But I did some measurement on asking questions to this type, and I'm going to tell you what I found, and then talk about why the responses come back kind of bother me. And it ties a lot to the previous talk, too, because it's another measure of kind of the complexity of what we're getting into. So qtype equals any, we want to stop that. I'm not arguing with that. And I'm going to just keep on going. And so what this RFC says is that there are 3 ways that anyone can respond to a qtype of any. 1, answer is a subset of available RR sets. In other words, don't give everything out. It's not everything, it's anything. So just give out a few things out there. Or 2, use a synthesized hinfo record that basically indicates that I'm not telling you the truth here. This is just one record out of many that might come back. And 3 is try to guess what the person really wanted. There's a third approach. These are the three main ways of responding. And what has me a little concerned about this is actually in the draft itself. The italics here are copies right out of the draft itself. First one, if I just take a subset, there's no way of indicating that that subset isn't the complete set of what's available. It's just not available, not able to tell you that. Two, the hinfo shouldn't tell you much more than you're getting the hinfo back. And three, it says in some areas you might be able to guess what the intent was, but not always. And one thing I've learned over the years in DNS, when you get a query, you don't know why someone's asking, so it's really hard to guess what their intent is. So I think this one's really kind of hard to keep around. Now, let's see. So I want to clarify my complaint here. I'm not complaining about the qtype equal any being disabled. I'm not against pulling it out of the protocol. I'm concerned about the way we're telling the querier that this has happened. We aren't really signaling very clearly that we've made a change to the protocol. This is a new way of answering it, so if you expect the old behavior, you've got to change or drop. Stop doing this. We have a history of doing this in places that are probably bigger concerns out there than this case I'm talking about. The R code we use out there, R code meant for serve fail, a lot of times means the name servers you want to go to aren't responding, so there's a service failure, you can't get there. But for DNSSEC, we use the same R code to say that the validation failed. And that's been a cause of concern in many places. I hear people saying that they don't understand DNSSEC because serve fail, is it because I couldn't get the records or I couldn't validate the records out there? The other example, this is the TXT record. For those of you, some people may remember this from a long time ago. SPF and records came out as a way to protect mail. What happened was the original developers of the SPF idea were told you can't have your own record type until you have a real reason for having it. So they built up all their code around the TXT record to get it off the ground, get it running, showing they had some proof. When they got there, they were ready to go deploy with TXT records. People said, no, you should have the SPF record. I said, well, we already invested everything in the TXT record. It's too late to change over. It's not worth going over. And we've changed policy since then about resource record types and so on. But we have a history of overloading things within the DNS, and it's getting more complicated. The previous talk fed into a lot of these concerns. So before I go to this slide here, let me tell you what I was doing, what I am doing. I send a query type, a qtype of any, to the TLD name servers. These are name servers that are authoritative for the top level for TLDs. So you have a pretty good idea of who's actually running them. They're also for the apex, so you really know what records are going to be there. In fact, my code can tell, it's actually very accurate, whether or not I've got a reduced to any response or I get the full response by, do I have an NS record, do I have an SOA record? If there's DNSSEC, do I have these records or these records? It's pretty accurate because I know who I'm asking and what I'm asking for. But that's not always the case, and that's the fear, uncertainty, doubt part of the talk later on. So I took this code that I use for pulling data in every now and then, and I configured it to just go ask all the name servers out there for the any type, and see what I got back. And I TCP, UDP, both of them. Almost 14,000 name servers fit into this in UDP and TCP. That's all the TLD name servers out there. Maybe not all the names that I really want to care about, but that's a good sample set to look at. And I got back about 250 or 260 responses that indicated the any query was being reduced. Now, one thing is that's a very small percentage. And if you really want the any query to be reduced, we got to do better on getting it to go there. You really want to get that number higher. Two is that the number is different between TCP and UDP, which kind of surprised me a bit, because the RFC didn't really make a difference in the two transports. And finally, when I was writing my code and I hadn't gone through all the implications of this, I found that there were 9 or 10 different ways I was told the any query wasn't being honored. And that's what I was mostly concerned about, was the fact that there were so many different ways I got back. And as I tried to drill down on this, I realized that I was trying to guess why people made choices. Why did the operators go with one record or another record? So I did a little bit of work on that to try to figure out what's going on here. So I have statistics here at DNS-OARC. There's not a lot here, but this is what I have. In UDP, I asked that many queries, got so many responses. Outside of UDP, there were a lot of truncated. Most answers came back truncated. That makes sense. This is UDP, so we don't want to send back the any response to a TLD there. I got about 768 valid responses in there. There are quite a few ccTLDs out there that are still not DNSSEC signed, so they fit in there a lot. And I have 260 others, and I got this other pie chart. Now, what I like about pie charts is that I don't really care so much about the numbers, but when you see lots of little pie segments, that means there's a wide spread of stuff happening. Right? It would be great if that last chart only had here it is or here it isn't, but we don't. We have all these different pieces in there. Inside there is the empty answer was in there, which I'll mention later, sooner. The hinfo is in there. That's that special case. The hinfo has been synthesized. And the other ones are just single types that are whatever was thrown back. TCP, I did the same. Same thing here, except there's no truncation in TCP. Not surprising. And again, I have a fairly wide spread of what's out there. Now, one thing that can be a little misleading here is you look at the size of the pie pieces. You can't take too much from that because a lot of times the same operator does the same thing for a dozen zones. So there might be an overcount in some areas and certain presentations. I haven't quite get into that, though. I tried to look, though, to find out, is there any pattern to why people chose a certain type or not? And so what I did there is I looked through and I took all the responses back and I asked each IP address, what code do you have? Version.bind. Now, version.bind is not a very accurate way to get implementation information out there. We know in general people will mask it out. We don't like the idea of it. But I thought I'd try and see what was out there. Surprisingly, I got a lot more information back that way than I expected, especially because I'm asking the TLD zones out there. I think some people are not as afraid to use it there, but they might be in other parts of the world, or other parts of the DNS world, I mean. And I was able to pull out some of the implementations that they're and say that they indicate they were one of the open source vendors out there. Now, I didn't name names in here, so I just have these. These are the three. I saw three implementations that they were self-identifying as implementations. Those that said they were implementation 1, they had 10 empty answers, 5 with NS only, and 1 that was SOA only, which isn't not too surprising, but it's out there. Implementation number 2 had no empty answers out there. They had everything was NS only in there, and implementation 3 had a few more different response types out there. Again, the size here is not that meaningful because sometimes there are overcounts, the same IP address, same operator, and so on. But the two sizes are about the same. So I was, in doing this, I was trying to tie back, well, how can an operator manage to answer this way? So I looked at the implementation, I looked at the documents for the implementations out there, and NSD has a refuse any type in there, which says that it will truncate UDP, or it will just make TCP act like it's normal. Bind has a minimal any, and it said it will pick the first one found out of cache, or first one that's in the authoritative data store, and just send that back. Both these default to no. For not in Power DNS, I didn't find any documentation saying how you could configure it, but I did find email threads from support communities saying, we don't do that, and so on and so forth. This is kind of surprised me because now I have 2 implementations that do say how to do it, but 3 of them do something. And the 4th one says they don't do anything, and so that one's probably the same. But there's no lining up of what I see in configuration options with what I see in observations. It's possible that the version.bind isn't wholly accurate. That's one possibility here for why it could be that people are saying that they're running not when they're actually running NSD, for example. They could be doing that. I didn't look that far into it. So I'm baffled by this. Now, I really can't see any evidence of why operators are going one way or the other in the choices they're making here. I mean, this is kind of like they're rolling the dice and seeing what comes out there. I'll just keep going. So why this is bothering me, I don't really want to save any. I don't really know that we have to go back and fix any to have a single way of saying no. But this is not the first time we've overloaded some part of the protocol, and I guess that's not a surprise to anybody. That kind of makes things kind of fuzzy out there. I'd like the protocol to be simpler. One person had suggested to me a long time ago that every protocol should be like a state machine out there. What happens inside, every time you get a message, you go through another state of the machine, very predictable. You know what's going on, especially from one end to the other. You want to know what the other side's thinking. I had a discussion with someone after the talk, in email, and he suggested, well, that's not ever going to happen in DNS anyway, so we might as well give up on that. But we'd like to be there. So let me go on. This I said before, this is what I was asking for was the queries out there, but in general case, the last bullet here is what I want to still talk about. In general, if I'm not asking an apex of a TLD, I'm not convinced that I would really know the difference between getting any or just getting a subset in one shot. Now, should I be, for those who think that I'm harping about a molehill, making a mountain out of it, it's a fair question. Should we care about this? I mean, should I know whether or not I'm getting any query or not? And I'll acknowledge that that's, this may not be the most important thing to solve in the world. The other concern I have here is that I've had experience in operations over long times, and I really think we want to make the protocol simpler to understand. The more complex it's getting out there, the harder it's going to be for folks to implement the code, for those we bring in to run the code, to debug the code, manage the code. I think this is an example of we're going in the wrong direction. We made it so that there's not one simple, we don't do this anymore, tell the customer this. It's got this, we now that's kind of this muffled response coming back. Not muffled response, a muddled response coming back. And I'm going to kind of skip through these last 3 slides here because these were done before my other discussions I had. We know protocol engineers, operators, software developers all have different roles to play here. We're trying to, the protocol, make more functions. Operators are trying to minimize downtime. So what I've been trying to do here is just trying to bring up a case where I think that we've made a step in the wrong direction by letting the protocol go to a fuzzier area because of convenience. It's easier for us to just have the protocol respond this way. Now, I had a discussion, or there were 2 things, I guess, I want to bring up. During the talk last time, first thing someone came up to me and said, I'm a recursive service person. I read this document, and it doesn't talk about recursive servers out there. I thought, I didn't even think about that. That didn't even occur to me. I've always done authoritative work in my life. I've never worked with a recursive server out there. But it shows that there's a gap of those who are implementing and running recursive services did not seem to have any of the opinions brought into this document. Another person went back and forth. I asked him some questions about what was the process here? Why did we wind up with this? And he made some pretty good observations. One is for the hinfo option, you have to do on-the-fly signing if you have a synthesized record. And code that he was writing was not doing that. And so that option wasn't open for him. Now, my reaction was, well, I've been in places where we pre-compute possible responses out there. You could do that, but maybe that's not the best thing out there. On the other hand, choosing anyone you have, that's very expedient to come out there, but still it's kind of like rolling the dice and you're getting what you're getting. And operators are increasingly relying on the tools we get. They're not making the choice, the code's making the choice in a way that may not be obvious to the operator. And I guess that makes the points I have here and those here. I did have one last thing I was going to add to this. I was thinking about the discussion I had online and in person about this. And I know this is not the IETF. We're not trying to fix this. But here's a question for people. What if we actually just said it, instead of this approach for shutting down the any queries, what if we just create a record that the any query record type has a message saying don't ask? And so when you ask for the any query, you get back an any query, and it's an any record rather. And that's just a query if anyone has any opinions on that. But then again, I'm not sure we really want to solve that. So I will end here. I'll look for some discussion about this, see what's on the minds of people, whether it's about the process of modifying the protocol or about this particular case. But are there concerns about the protocol definition being fuzzier over time or not?
Hey, Tail, and this is both to you and to Wes. How about extended error? I mean, now we have a new type coming in, EDNS facility for being able to clarify a lot of these fuzzy cases. So,
actually, that's actually a point that I forgot to mention. One of the things that the reason why some proposals come up and people say don't notice because it takes there's this unwritten rule that takes decades for things to roll out, right? I think we should challenge that. And I think it's worth, because for the KSK rollover, we had that RC 8145. which is measuring something. And we noticed that was adopted pretty quickly. We got a lot of stuff coming in right away, which showed that people had updated their software to include that. So maybe other approaches might be more reasonable because we do have operators that do refresh technology faster. So.
Hi, Evan. I was one of the co-authors of 8482, and in particular, I was the one who came up with the returning a subset of the RR set. Mm-hmm. And I'd like to make a couple of points. This also addresses why the document doesn't discuss resolvers. The behavior of any on resolvers, recursive resolvers, and authoritative servers was already different prior to this change. And the way it has always worked for resolvers is the resolver will return whatever it happens to have in the cache for that name. And if it has nothing in the cache, then it will send an any query to the auth and get a full any answer back, and then it will respond with a full any answer. But if you're a client depending for some reason on a complete any response to a name, and you're talking to a recursive resolver, you already had to be able to deal with the possibility of getting partial results. You've always gotten partial results. It's always been there. So to my way of thinking, this is not making the protocol more complex at all. It's actually making it simpler by removing an exception. Any server can now return a partial RR set to any, and we just learned to deal with that. We should have learned to deal with it already.
Yeah, I don't have a problem with where we wound up. Well, first, let me say for the first thing about recursive servers, I was interested. I got the question because whoever wrote it, the person I was speaking to, looked for the recursive stuff in the document, saw it wasn't there. But you're right. I mean, we weren't changing recursive servers.
No.
But there still is an audience out there that wants.
Admittedly, I'm not sure that behavior has ever been in a specification explicitly.
Yeah.
But I know of no recursive resolvers that ever worked any other way.
Yeah, and I guess, and the other thing too is, my concern here is that we've changed the protocol.
Except I don't think we have.
Well, we've.
I think we've removed an exception case that shouldn't have been there in the first place.
I remember I wrote 3 or 4 clarification documents in the last decade where people say they aren't clarifications, they're always changes. So it depends on, if you're looking for, doing what you're saying is true, but some people consider that to be a change because now I don't have the expectation that I get everything back. So,
anyway, thanks.
Sure.
Hi, Vixie. I think the essence of 8482 is that we would like to live in a better world that has fewer undefined things that cause phones to ring, but that we didn't want to break other older things that weren't coming into the future with us other than in their old form. So the purpose of this was not to in any way fix any or make it workable, because that can't be done. And so exactly which useless answer you send back is a matter of, I don't know, art rather than science, because all we're really trying to do is to have some old ICS device bolted to the wall in a factory somewhere, make an any query, and get back something that causes it to do the right thing, whatever that is. In other words, to not take an error path or dump core or offer its memory for inspection by the attackers or anything like that. So as long as the answer that comes back is something that older clients won't throw up about, we're good. Because if anybody releases a new product whose code has been touched, maybe it's a upgrade to an old product or maybe it's a totally new product, but if you're touching code and you don't remove the place where any queries are generated, then you are out of compliance because any has been deprecated. So if you do this in new ways and then you're counting on some specified behavior, then you're missing the point that any has been deprecated. The only thing we care about is older clients whose source code has been lost and will continue making any queries until the sun burns out. So I think that the arbitrary, unpredictable nature of what you get from any is a feature. It is meant to be painful. Thank you.
Okay, so what you said kind of contradicts what Evan was saying. Evan was saying we basically were just relaxing a restriction on the protocol, and Paul is saying that we are deprecating something. If we were deprecating any, it's the same effect, but it's interesting that we have these different interpretations. I think this is what might be at the root of what I'm after.
Pardon me. It wasn't that I wasn't saying we were we were removing a restriction on the protocol. I said we were removing an exception from the protocol where authoritative and recursive behave differently. Whether we deprecate any or not is orthogonal to that question, in my opinion.
Well, the two are different. I'm hearing we're doing both, so yeah.
Brian Dixon, GoDaddy, just spitballing random ideas. What if the random thing that was returned for signed zones was an NSEC or an NSEC 3, and for unsigned zones was a synthesized NSEC? So you'd find out what records are there. I know it's kind of weird and evil, but it might be more useful as a response to somebody doing diagnostics.
Yeah, at the top of my head, I couldn't really answer. I mean, I don't want to dive into that, because I'm sure the authors were concerned about that too. So.
Yep.
Ralph Wilmans, NL Labs. Regarding the observation that the same implementation has different ways of minimizing the queries, is it possible that you are hitting any casted addresses here?
Most likely are any casted, yes. And load balance is probably even more of what's happening. That's why I'm saying the magnitudes aren't very interesting, because I'm not sure that I'm counting the same machine more than once, and so on, or I'm on the same IP address counting it in different buckets. So it's just interesting to see, and to be fair too, when I was discovering the implementation, I had one query go off for name.bind and another query go off for the any, and it could have been those two were, so it was just to give an idea of that there's a plethora, or there's a wide range of responses coming back, not what was significant in any way. That's why the magnitudes really don't mean much more than it appeared. At least one did this. So.
Any more questions for Ed? Right. Thank you.
Sure.
Next up, we have Libor Peltan from CZNIC, and Libor is going to talk about increasing the DNS response rate using XDP.
Good morning, I'm Libor Peltan. I'm from the CZNIC, and I'm the developer of NodeDNS, the open source authoritative DNS server. When talking about performance of the server, for authoritative server, it's usually not a big deal. The performance regarded to the legitimate traffic, because the legitimate queries to authoritative servers are not so many. For recursive servers, this is completely different story. But in any case, also for authoritative server, there is always the possibility that there is some attacker who tries to flood the server with millions of queries per second, and thus making it not answering to the legitimate traffic. The best response to this is to have the authoritative server powerful enough so it's able to answer all the queries. So we, as the developers of NodeDNS, are sometimes asked how many millions of packets per second is our name server able to answer. And when the question is performance, the answer always starts with a profiler. So I made a profile, and what I can see that roughly tens of % of CPU time is spent on those two Linux syscalls. And those are syscalls responsible for receiving and sending a packet or multiple packets. And also what is not seen on the profile is that even more CPU time is spent on the receiving and transmitting routines in the Linux kernel itself, because the profiler only sees the user space time. So what can we do about that? Is there a way to bypass the Linux kernel routines completely so that we can receive the packet directly from the network card to the DNS server? Where there is a brand new way. It's a completely fresh technology, and it's called XDP. And you can see two shortcuts here. The XDP is the way to hand over the packets from the network card driver directly to the user space program. And BPF is like a switch responsible for deciding if the packet goes to this XDP bypass or it goes normally to Linux network stack. So more to those two shortcuts, what do they mean? The Berkeley packet filter started long ago as a firewall implementation, but it differs from other firewalls that are based on some rule chains. Here, the firewall rules are consisting of a program, which is actually bytecode. It can be compiled from, for example, a C language. And this bytecode is once uploaded to the network driver, and it's called like a callback whenever a packet comes, and it can decide what the packet will do. This bytecode has some limitations. For example, it cannot contain any loops that are not unrollable during completion. And this BPF program can decide if the packet shall be dropped or redirected to this XDP or normally processed by Linux stack as usually. And what is those express data path? Well, it's like a set of shared memory buffers that can be allocated either for receiving or transmitting packets, and the network driver puts the incoming packet directly into one of those buffers, and the user space program can directly manipulate the contents of the packets in this shared buffer. So all in all, it works with no copying in memory back and forth of the packet payload. What are the requirements of this very new technology? Well, brand new Linux kernel, or at least somehow new. For actually gaining the zero copy advantage and to achieve some better performance, it is also good to have a compatible network card driver. And the user space program must be running with additional capabilities, or at least started with those capabilities and drop them later after initialization of the XDP. There is also a helper library called libbpf, which helps us as developers to implement this feature. But among Linux distros, this is poorly in their repositories because it's quite new. For example, in Debian, it is normally present, but in Ubuntu, there is no such package. So we decided to embed those libraries temporarily into our code base so that it would work on all systems. What is the consequence of all this approach? Well, the Linux firewall is for those packets that are going to our user space program is completely bypassed. So all the rules in the firewall are skipped. And for the sake of simplicity, we decided to implement it only for UDP for now, because it's stateless still. And if we decided to implement also TCP over express data path, we would need to re-implement the TCP stack, which would be most difficult. And the packets that are not like suited for this speedy approach, we can simply let them go normally through the Linux stack, and it will maintain the functionality of how it works without XDP. And also for sending the packets, we also use XDP. So when sending the packet, we must know the target MAC address and the target IP address. So we simply do symmetrical routing. That means that when the query comes to us, we have the source MAC address, so we send it back. So this is not suitable for setups where the routing is more complicated, but I hope that this is not the case usually for DNS servers. So when this all implemented, we immediately started to measure the results. how fast it can be. And I was pretty much surprised. Please note that those results are very artificial and are on some very aging hardware. As you can see that the absolute numbers are low for all the setups. But in general, the first use case is the very small query and answer. That means that there is almost no CPU time spent on actually the DNS answering, and most CPU time was spent only on the network routines. So you can see that this improved significantly. But for the DNSSEC zone with NSEC 3, where most of the CPU time is spent on calculation of the NSEC 3 hashing, the improvement still was visible. If you like graphs, I don't. So what we have learned, I also have some additional observations to this implementation. I've seen minor improvements of latency, but we have observed some issues with kernel itself, which tended to some kernel processes were behaving weirdly, and once I also encountered a complete kernel lookup, but it was in some experimental setup. And it was also more difficult to balance the CPU thread usage. So how the implementation is, what's the state now? We have implemented it for now in the development branch. It is not yet accepted to master branch. But anyway, we decided to create some experimental packages for let anybody try it out. So if you want to experiment with this implementation, ask me or some of my colleagues on mailing list or anywhere. And also, I have a notice from my colleagues from NotResolver that they are also going to implement this technology in their project very soon. I hope this year it will be usable, at least somehow. And I would like to thank especially to my colleague Vladimír Čunát from NotResolver, who came with this idea and helped very much with the implementation. So thank you, and I welcome some questions.
NRA, Apple. Thank you, Libor. Very interesting approach. I have two questions. These initial measurements you did, were those done with IPv4 and IPv6? If so, did you notice any differences? And second question would be, you mentioned that BPF takes the decision handing over to XDP or handing over to the kernel. Under which circumstances, you had like IPv6 extensions on that slide. Under which circumstances would you hand over to the kernel?
Okay, so to your first question, those measurements were done on IPv4. On IPv6, we have not measured it actually, but in theory, it might be a little worse because for IPv6, there is obligatory to have some additional UDP checksum in the packet, in contrast to IPv4. So there is additional routine which take some time. So I expect that the IPv6 would be like slower for tens of %. And what was the second question, sorry?
The decision logic of BPF when to hand over to the kernel, especially when it's IPv6 traffic.
So this logic deciding where the packet will go, it's the same for IPv4 and IPv6. And we simply receive the packet and see if it's the basic UDP, DNS over UDP packet. That means it's not fragmented, it's not TCP, it's not different port. And if all of those are okay, then we handle it to XDP. And this does not differ between IPv4 and 6.
Okay, Thank you.
Hi there, Brian Summers from Cisco. You mentioned that a lot of the CPU time spent in NOT is calculating NSEC3 hashes. Is that just, and maybe this is beyond the scope of this talk, is that just for negative responses? I assume that there's a map of positive entries in the zone for...
Yeah, sure that NSEC3 hashing is only done for negative responses or some responses that require it, but for example, some white card. But yeah, mostly when the attacker tries to flood your server, he sends you queries that are actually for negative responses.
Okay, thank
so
you.
This is the reason.
Hi, Ray Bellis, ISC. Does the XDP stuff all happen after, for example, flow hashing on the NICs? Do you know about that? Because you're saying about having misbalanced CPU load. So what I found in my own experiments is that you have to have a very high sort of source address or source port entropy to make sure that the flow hashing algorithms actually balance the traffic evenly across the different NIC queues.
Yes, this flow hashing can be turned on, and it's not influenced by XDP. It goes before because it's done by the network card just before the BPF goes into effect. So this is not affected, but we faced some difficulties when the packet actually comes to the thread that the CPU threads are not aligned with some threads in the network card. So sometimes it happened that the packet goes to different thread that previously, and
I've used this on raw packets where you can say deliver it to this particular
So this
CPU
flow
core.
control, we take care of it, and it helps us very much because otherwise it would just come into one CPU thread. But anyway, there were still some difficulties with balancing the CPU cores.
Yeah. Okay. Thank you.
Hi, this is Anand from the RIPE NCC. So just to follow up on Ray's question, have you looked at also doing CPU pinning of any kind to see if you can align the packets coming in with the appropriate process?
We do this for the normal operation before the XDP came into effect, but now we are simply too fresh to do all this like tuning. We are happy that it at least works somehow, and it will go for more development in the future.
Thanks.
Thank you.
Thank you, Libor. Before we start the coffee break, I have two announcements. I would like to thank our sponsors, so that is Comcast for being the deluxe sponsor of this event, and VeriSign for being our annual patron. We are still looking for sponsors for the next workshop in Paris, so if you're interested in that or in becoming annual patron, please come see Dinesh. And second announcement is that at the end of this day, we have a slot for lightning talks, and we're still looking for submissions. So if you have anything you would like to tell in 5 or 10 minutes, then please submit that to Indico. With that, we can start the coffee break, and we will be back here at 11.